Yeah, I think it's important to keep the customer's project scope and budget in mind. You can always, reach for the superlative solution, but really for the customer's pocket, is it really the best thing? We ask ourselves, what is it going to do? And they're like, oh, I just want to drive it on Sundays. It'll be fine. We don't need an F1 level harness.
Welcome to the HPA Tuned In podcast. I'm Andre, your host, and in this episode, we're joined by Kevin and Philip from Technica Racewire in the US. This business is established to essentially build production run harnesses for classic Porsches, and this is an interesting business model, I think, where you're focusing on such a niche product, although obviously still a very popular product. However, how do you go about designing a harness that's going to suit such a broad range of people? Maybe people wanting to retain the factory ECU but freshen up wiring that might be a few decades old. Or alternatively, there might be people who want to introduce an aftermarket ECU to give them some tunability with their engine. Maybe they want to eliminate the distributors and go to a coil-on-plug setup. And we talked to Kevin and Philip about how they design their harnesses with this in mind so they're adaptable to suit the end uses of the particular application and the particular person that's purchasing them. On top of this, we talk about how they establish the business in the first place, their background, what their skill sets are, and how the business has essentially grown over the time they've been running it. We talk about some of the intricacies in developing and working with a sealed race spec, or Mil-Spec as it's often referred to, harness. Obviously, one of these harnesses is very difficult to modify once it's complete. How do we go about adding in extra functionality that maybe wasn't necessarily obvious when the harness was being designed? We also talk about some of the intricacies of working with Autosport connectors and what are some suitable alternatives that aren't at that Autosport price point but still work and are incredibly reliable at a race grade level. Of course, no discussion on motorsport wiring would be complete without a bit of a discussion on the age-old debate of solder versus crimping, and we get Philip and Kevin's take on this topic. Before we jump into our chat, for those who are new to the Tune In podcast, High Performance Academy is an online training school. We specialize in teaching people how to build performance engines, how to tune EFI, how to construct wiring harnesses. We also cover topics on fabrication, 3D modeling and CAD, race driver education, and data logging, just to name a few. You can find all of our courses at hpacademy.com/courses. All of these courses are delivered in high-definition video modules that you can watch from anywhere in the world, provided you've got an internet connection. This means you can learn from the comfort of your own place and you can learn at your own pace. All of our courses also come with a 60-day, no questions asked, money-back guarantee. So if you purchase them for any reason at all, decide it wasn't quite what you expected, no problem, let us know. We'll give you a full refund. And for podcast listeners, you can also use the coupon code podcast75. That will get you $75 off the purchase of your very first HPA course. We'll put the coupon code in the show notes to make it nice and easy for you to find. Lastly, if you like free stuff, then I've got a great deal for you. We are constantly partnering with some of the biggest names in the aftermarket performance industry to give away some great prizes. You can always find our latest prize at hpacademy.com/giveaway. It might be an aftermarket ECU or dash. It could be some engine components or engine building tools, or just about anything in between. They are great prizes and we will ship them free of charge to your door if you're the winner. There's no tricks here, no purchase required to get your name into the draw. All right, enough with our introduction. Let's get into our interview now. All right, welcome Philip and Kevin to the podcast. Thanks for joining us today. And as we always do, let's start by finding out how you got interested in the automotive scene.
So, a little bit about me. I got into the automotive ever since I was a kid. And my father used to bring me to the LA Auto Show early on. I got a bunch of albums from my dad's film of him like attending the LA Auto Show since he had came to the United States. Some old flicks of 964s and Celine S7s and stuff like that. And then when I got old enough, we'd take the train and visit the convention center in LA to go see cars. Ever since I could turn a wrench. Maybe like 9 or 10, he'd start to show me like this is like how you replace like an air filter. This is how you do oil changes. And then progressively he made it a little bit harder. We're gonna do brakes this time. We're gonna bleed brakes this after that. And then I just got my hands dirty really young. And yeah, just we loved working on old cars. Our family is just full of Toyota fanatics.
I love an old Toyota. Unfortunately, old Toyotas are also exceptionally good at rusting. So at least here in New Zealand, it's quite difficult to get the older Toyotas that are still in pretty good shape.
Yeah. We have like, Mark III Supras, and, I have an 81 Starlet that my brother and I want to put a beams in. And
Yeah, nice.
like just, like being raised in that culture of like modifying cars and doing little things to make it better. I think my dad knew I'd be a car guy, so he gave me like a really crappy car on purpose. He gave me a 5-speed Camry, like a 2007 Camry. And even then, that wasn't enough to contain it. I started thinking about Arion parts that I can slap on the Camry, lightening the flywheel, and doing dumb things, slamming it to the ground, putting Enkis on it, all that stuff. But then I realized, like, oh, should probably do it to a car that's kind of purpose built for that.
Yeah, it's always important to kind of give some consideration to the base model. I mean, obviously, if you've got the budget, anything's possible, but sometimes it's going to cost a lot more to get a worthwhile result on a given platform rather than starting with the right platform from the get-go. All right, so Toyota guy at heart.
Yeah, Toyota guy at heart, JDM, like just old Celicas, old Corollas, that type of stuff.
Okay. Mm-hmm. All right, Philip, give us your backstory quickly.
Yeah, so my name is Philip. I'm the CEO of Technica Racewire, and I started later than Kevin. Grew up with Kevin. He's my neighbor growing up, and I think around college I had my first car, which is a Toyota Camry, and didn't have a lot of money. And Kevin helped me out a lot how to like fix and maintain my car again and again, and that's how I was able to like get my hands dirty. From there, I joined SE Formula at Cal State Fullerton. My background's in mechanical engineering, and dive really deep in towards just kind of how like designing the chassis, the aero kit, and even just like being on a team is definitely very like in that area I learned how to be creative instead of just all technical, but creative in the sense of like how to come up with solutions on the fly. And from there, Kevin and I had like some project cars like a Mercedes 280 SL that we tinker on together with like the neighborhood mechanic. And I guess from there, that's how I got into cars. Just kept tinkering, building stuff. And even my side projects, I've liked to build other things like an electric skateboard or work around my house or a go-kart. So definitely I like to just build.
Okay. If I'm joining the dots here, it sounds like when you started your mechanical engineering degree, maybe at that point the cars weren't the passion and the direction for the future. So am I right in saying that? Why did you go down that mechanical engineering path?
So it took some time for me to like figure out what I want to do. I started off with growing up. My dad put me to a lot of work, like fix his house or remodel like some of the houses that he bought for property. So as I was trying to figure out my career, I had a lot of hands-on skills and knowledge that I didn't know I was acquiring as I was growing up. And from there, when I started tinkering on cars, things were like sinking in a lot faster than I was expecting. Like things were making sense. Even going through the struggles of working on my own cars and finding the satisfaction or everything works afterwards kind of put me in a path of like, I think I can do this by myself, or I think I can accomplish what I'm trying to do. I think something very simple is when I was doing my first brake job on my car, I was trying to change the drums. I didn't think it was that hard on my first time, but it took a couple of days. But afterwards, I was able to figure it out. But during that process, I was like, man, I don't think I can drive my car. I think I messed it up.
Yeah, I mean, brakes are pretty important. We want to be careful if we're working on those sort of safety critical systems for sure. All right, so at the moment I'm hearing a lot of self-taught mechanical skills, but that's very different from the skill set required to build a motorsport grade wiring harness. So can we kind of get some insight into how you both move towards doing wiring?
So my career took off doing a lot of aerospace on my side, and I worked a lot of avionics. I worked a lot of like aircrafts, so I was able to gain a lot of like industry standard like practices and designs. And from Kevin, he worked at Hyundai for a long time doing R&D. So we always kind of bridge ourselves in a sense of like, oh, we have like this is what we learn at work, this is what we learn like do our own research. So we're able to just kind of
apply what we did.
apply what we did. And then from there, we had a friend, his name is Amari. He had a Porsche 944, and he said, "Hey, Phil, Kevin, my car doesn't work. It's been sitting for a very long time, and I think there's an electrical problem. And I heard you and Kevin might have the brain power to figure it out." And I was like, "Yeah, like totally." So he brought his car to our garage, and our garage is like full of like all our tools, shared tools for me and Kevin. And we started like, okay, let's build like a full wiring harness for a 944 platform that's, that you can't get from the market. So like drafting designs and everything. And eventually, once we built our first harness together, everything worked immediately.
Okay.
It's actually like a 944 turbo, a 951. And I think that was kind of the spark of like, hey, like this is actually pretty cool. Like we actually had a quick success immediately, just kind of really taking our time, document everything. And Amari was really happy. He's basically our first client. And from there, he brought in like two more. He's like, hey, I got friends.
Yeah.
Like,
none of these cars go anymore.
Yeah.
And none of these cars are, please help.
Help.
They've been sitting on jack stands for about a few years.
Yeah, I feel that pain. My daily is a 964 Carrera 2, and there are some wiring gremlins going on in there. I've kind of just ignored it, put my head in the sand over it, because at the moment it hasn't left me stranded on the side of the road, but I sense that day is coming, so we might need to do something with the wiring on that car. I'm interested, that first harness you made for the 944, was that at the sort of full sealed Mil-Spec style concentric twist, or are we talking kind of more of a club level harness here? And we'll get into what differentiates those two styles of harness as we go.
Yeah, so it was more of a street, like a street car club sport level harness. A lot of it was definitely not sealed. I think it was more of, here's the cost, like we were just looking at the cost of materials and just racking our brains around, just taking the thing apart, figuring out, the way that Porsche terminated these things, going through the whole bomb. None of the parts on that bomb are ever like able to take any of the heat, even if you wanted to put like Raychem boots on that or anything. So we did away with that and just kept it really simple to rubber boots and connectors.
Yep, and there's absolutely nothing wrong with that. I think we live in an age now where any sort of automotive enthusiast is going to be bombarded on Instagram with pictures of these beautiful Mil-Spec harnesses. I keep using that term Mil-Spec, which is actually a term that I intensely dislike because it's thrown around so often, yet taken completely out of context. So I prefer motorsport grade, but I think we all know what I'm talking about here. They see all these pictures of these beautiful sealed harnesses and think that that's the only solution for their project car. And the reality is, of course, that's not the case, correct?
Yeah. It's a lot healthier, or it's better to look at it as, what we make, even at the club sport form, is a lot more robust than what it originally came with out of the factory. I mean, we use like this fiberglass loom tolerant up to 650C if you just held a flame to it. It doesn't have to be DR. It doesn't have to be like potted or any of that. And you can still get a result even with materials that it's not an F1 harness. Okay, that's fine. But as long as it has the appropriate materials for the environment that it's going to live in, I think those are notable concessions to make in harness building.
Getting a little off track here pretty early, but just seeing as you mentioned this 944 harness that you built, And I'm going to make the bold assumption here that you're working with factory Porsche electronics in terms of the engine control unit. How difficult is it to source, particularly at that point where you're not running the business you are now? I'm assuming you probably didn't have the contacts in industry that you've got now. How do you go about sourcing replacement connectors for the likes of ECUs? Obviously, Porsche use a lot of Bosch sensors, etc. So that side of things maybe not so difficult, but yeah, the actual ECU itself.
So primarily focusing on like just a restoration type of OEM plus harnesses and sourcing Porsche connectors. So my background's in mechanical. So one specific example is the DME connector or the ECU connector that's no longer available in the market anywhere. And so I took like the first Porsche harness we did, we used the connector. So we depinned everything and we used it. But I know over time, plastic over time degrades and becomes brittle, and that's a challenge. So I was exploring the market, like how can I make my own connectors? So I did a lot of 3D scanning, modeling, and even trial runs on recreating a mold, just so I can injection mold my own connectors. And that was like a pretty long process.
I can imagine.
Yeah, a lot of trial and error, but over time, currently, specifically for the DME connector, I'm the only guy who has that in stock, like a full box load of just
replacement aftermarket OE connectors, essentially.
Yeah, and I'm starting to realize, the Jaguars need those connectors, or some Mercedes as well, because they use the
Right.
same type of DME.
Or BMW, like E30s and stuff like that.
Yeah,
36s, they all
and
share a similar connector.
and then I made it my taste. Like I just made all the plastic black from this, prevent from discoloring. The original connectors are white, so it over time fades.
Yellows.
Go yellow.
Yellows, yeah.
Yeah, we've all seen that. I assume that you were still able to purchase the actual terminals for that connector. It's just the connector body that was the problem.
That's right.
Yeah.
Mm-hmm.
Okay, it's a novel approach, but I mean it makes a lot of sense. If you can't buy the connector, what are you going to do?
Yeah.
Yeah.
And I wanted to see how like my capabilities in reproducing something very complicated and in plastic too. So
Yeah.
So I was able to. I made molds a lot in the past, especially for composites. So I have that experience of, okay, let's just do it for plastic now in a very small setting.
Okay.
Mhm.
Right, let's sort of fast forward things a little bit. You mentioned, Philip, you're the CEO of Technica Racewire. How did you sort of decide, hey, you know what, there's a business here, let's go into business together and do this for a living?
So yeah, that's a good question. So Kevin and I were best friends. We grew up together and we're also neighbors. And as we started to do these Porsche projects on the side as we're doing our day jobs, so as like again, Kevin was at Hyundai, I was at Ankara, which is another aerospace company. And then we started doing these projects, and come in and filling more orders. Kevin and I were pulling late nights just to fulfill those orders, and we weren't sure if this is gonna be a serious thing until we had like a conversation like, should we quit our jobs and should we take that step forward, and who should really run the company and who should be the technical lead, or who's responsible for what. That's when it becomes more serious. And really the conversation of like me becoming the CEO is, I told Kevin, if you want to lead the company, you have to be the face of like customer support, sales, do the bookkeeping, networking, just kind of just everything outside of what an engineer would typically do, or a technical lead. And Kevin looked at me, he's like, actually, I don't want to do that. You're a lot better at it. You're always the one planning like every friend hangouts, gathering, or you're always the one who's pulling everything together in an event or a project.
So you've got that innate skill set by the sounds of it.
Yeah, and
I think it's really important with any business partnership, because I don't have the stats in front of me, but it's fair to say most partnerships don't last the distance. But I think it's really beneficial when you've got two people with different skill sets that come together with sort of a synergy in essence. Basically, the sum of the parts is the sum of the whole is greater than the individual parts, and also therefore I think to a degree trying to stay in your lane. And I liken this to High Performance Academy. My business partner Ben, his skill set is in online marketing, website design, and he's also really good at the big picture stuff. I'm more the technical side, so that's worked really well. We've been in business together now for 12 years, and like an old married couple, we have our occasional argument, and then we settle down, have a hug, and get back to grinding on. So I think the fact that you guys could recognise that one person was going to do the CEO role and another person was going to be more in the technical lead is really important. How long ago was the business founded? Give me a sense of the age.
It's about 2021 to 2022 is when we had the semblance of taking on those jobs. I guess 3 years now. We're 3 years. So 2022, I guess. And I think things got more serious as we entered into 2023.
From we've got obviously a range of people that listen to this podcast. Some of them are home enthusiasts, others already run performance workshops, and then there'll be those that are kind of on the fence trying to decide if they take that leap of faith and start their own automotive-based business. How did you make that call to sort of jump from the security of a weekly paycheck and sort of roll the dice and hope it all works out? So how do you build the confidence to do that? Because that's a huge call.
Yeah, I think it was about setting at least on my end, it was about setting a precedent of like just having faith and going for what you want. And, I think I picture myself to be a pretty ambitious guy. And I think I would have a lot of regret not trying my best and taking something all the way, and instead of just getting in my head and leaving things as a road untraveled kind of thing. I worked at Hyundai for almost 3 years. I was doing EV R&D for a while, and I had a background in like solid state physics. That's my degree is in physics, and I had a minor in math. And I'm not gonna toot my horn, but I always got a job offer from like a competing OEM, and like I took that and I said, hey, if somebody wants to hire me, I can do that after I try this.
Yeah, that's a good point. So basically, you've got that fallback. If it doesn't work out, you can just go and get another job. I think that's important to look at as well. If you're starting a business, you do want to sort of consider what your fallback position is going to be if it doesn't work out. But, you try something, and if it doesn't work out, your worst case scenario is you get another job. So your worst case scenario is most people's everyday norm. So it's not that bad.
Right. And I think what is that bad is I think a lot of people are passionate about, pursuing an idea or they believe in themselves to a certain extent of what they can do. But I think like what's really defeating is that sometimes they, doubt themselves enough to not start that journey and just settle for stability in that way.
Another thing I've seen with even some friends of mine who want to do something in business and have the security of a day job, they kind of almost look for any excuse to not take that next step, kind of stuck in this analysis paralysis, or maybe they're building a prototype of their product that they're going to sell. And I would always try and do a sort of a test the market with a minimum viable product, rather than trying to have it absolutely perfect and completely polished. Take it to market, get feedback, iterate and improve. Whereas I think a lot of people will let perfection be the enemy of good enough. And nothing's ever going to be perfect. So if you're looking for perfect, you'll probably never end up hitting the market.
Mm-hmm. Right.
All right, so moving on, let's kind of bring up to date with where we're at with Technica Racewire today. So where are you located, and what's the sort of size of your facility?
Yeah, so Technica Racewire is located in LA, primarily in the city of Cerritos. And so it's basically a nice midway point from Orange County and LA. And LA is a huge hub, or I guess LA County is a very huge hub of just the car enthusiasts, a lot of shops around the area. And our current facility size is 3,000 square foot, and we have approximately 6 people altogether working full time. And majority of the people are engineers because we need a lot of brain power to even accomplish what we want to service as well. Yeah, and then we have like a couple of techs as well.
Right. Give us a sort of a quick rundown for each of you on what your sort of usual day-to-day looks like in terms of the roles and tasks that you're accomplishing within the business. Let's start with you, Kevin.
Oh, yeah. Most of my stuff is operations and technical development, technical direction, just meeting with some of our engineers on, their progress on certain projects, keeping in mind like how much time they've kind of dedicated to finding a solution. Like you had elaborated before, sometimes perfection's really the thing to paralyze all of us engineers. I'm super guilty of that, especially when it's like it's a nice harness that I want to make. But at the same time, I try to have us have like good reality checks on like, hey, this is an iterative process. We'll get this harness finished. We'll do our quality checks and then we'll take it to the shop and then see what they have to say about it, rather than just getting stuck here and figuring out if it's going to be on the mark or not. We're usually pretty good about how well we make our stuff, but again, perfection is an illusion sometimes, and it's good to hear feedback from shops.
Mm-hmm.
Yeah. Okay.
Yeah, most of the time it's just checking in and understanding where we are with our projects, making headway with techs or engineers leading said project. Sometimes it's going to other shops and doing support on installs or finding bespoke custom solutions. Sometimes it's taking calls on configuring engine management. It just depends what the day feels like throwing at me.
Okay. I want to dig into that engine management configuration in a moment, but quickly we'll give Philip a chance to answer the same question. What's your day-to-day role look like?
Yeah, so my day-to-day role is a lot of phone calls and customer service. So I usually create full build sheets or consult with them about what they need for their builds. And then I deliver all that information towards the team, like Kevin and my techs and engineers. Like, okay, here's the next project. Here's what's discussed, and here's like the lead time and what we need to buy and what it'll
Scope
look
of
like.
work.
Yeah, scope of work.
Yeah.
Okay.
And then if I've noticed over time, my timing decrease where I think half of my time I'm building stuff, but it's becoming less and less as we continue to grow the business more. So
That's a really good point you make there. I've talked about this previously on the podcast, but a lot of people who are good at something start a business and then realize that they are only spending maybe 30 to 50% of their day doing the thing that they're good at, the thing that they love, and then the rest of the time is spent doing the business things that are critical, but maybe they're not so passionate about that. How have you two collectively found navigating that, actually the operations of running a business?
Kevin and I divide up our roles, and like I do a lot of the stuff that sometimes I don't enjoy, which is taxes or working with accountings or
I don't think anyone enjoys that.
yeah.
Payroll.
But those are things that have to be done, and I'm good at kind of keeping up with those routines that keeps things going throughout the day. But I also have a huge technical background when I can also support and advise and even deliver like the right information, or project management as well, where I try not to give something unrealistic.
Managing expectations.
Yeah, manage expectations.
Understanding scope of work, just good enough, stuff like that. Yeah.
Mm-hmm.
Okay. If you're a fan of the podcast and you're interested in topics like engine tuning, automotive wiring, performance engine building, 3D modeling in CAD, or anything else in the high-performance industry, I have something that you might be interested in. Introducing the High Performance Academy VIP package. This package of courses gives you lifetime access to all of HPA's online training for one price. These courses cover everything from tuning and reflashing petrol and diesel engines through to motorsport wiring, engine building, fabrication, design, car setup, and plenty more. Right now, you can get $500 off High Performance Academy's VIP package using the code podcast500 at checkout. Becoming a VIP means you'll never pay for another course again. You'll get instant access to all 40 plus courses we currently offer, plus every new course we ever release in the future. Want to define maps or tune with WinOLS? Curious about CAN bus devices or how CAD can help make your dream build a reality? These in-depth topics, as well as many others, each have their own dedicated course that are going to help you master whatever it is you want to learn. And as a VIP member, you're not just getting the courses, you'll also join HPA's online community with lifetime access to our member forums and members' webinar lessons. Again, the code is podcast500 for that $500 discount. Just head over to hpacademy.com to check out the full VIP package and everything it contains. All right, let's get back to the episode. Now, I'm interested more around the work that you're producing, the jobs that you're taking on. I'm just getting the feeling here that you're doing some kind of production level work where it's not a one-off harness. I mean, I'm guessing that there must also be one-off harnesses, but are you doing sort of production run stuff as well?
Yeah, so our bread and butter is Porsche 911s and 964 993s. And what the company started form or become what it is right now is that we focus a lot on EFI systems for the air-cooled 911s. We know the motors really well. They all look the same, but they're not the same. And we starting to pick up like all these different induction systems that people like to use, different systems, different displacements, and because of the community of Porsche, everyone wants something different all the time. So we do production in a sense that we have a lot of pre-made items, and we can pull the harness together.
Yeah,
Where
modular system.
yeah,
Right. So not every harness you do is a one-off in that regard. Like the core of the harness essentially will be the same for a 964, and then you might have additions based on what the customer actually requires for that particular job.
exactly. Like one example is early case will typically be a single spark or single plug system, but then as later cases or 964, 993, they usually come in twin spark. So that's 12 coils altogether. And we're able to even create our own system where we support core unplug and fuel injections and even where to place the ECU, what ECU works really well. Yeah, just kind of be like a master in like all of that because the Porsche 911s, people want different configurations, but we try them all from our standpoint. So I guess kind of production level, more on a club sport level, the motorsport grade harness is very hard to productionize that. So those will always feel and be like one off, but we already know the specs. It's just more like building it one by one.
Okay. Coming back to ECU brand, and obviously if you're doing motorsport wiring, you don't need to be a tuner. But I think there is a crossover here because having a really good understanding of the ECU, how it functions, maybe any kind of intricacies around how to wire the likes of where the sensor 0 volts go, maybe the shield drains, etc. I think if you're familiar with a given brand of ECU, it just makes everything a little bit easier rather than trying to wire up 10 different brands of ECU, and there's a bit of a learning curve that goes with them. What brands have you sort of ended up aligning yourselves with?
Yeah, most commonly, I think in the Porsche market, everybody likes Motec. But, after understanding people's goals and finding the right system that doesn't really need to be a Motec, if you don't need to pay for a Motec, there's other routes in budgeting that money to still give a really good result. Mtron, there's Max ECU, or like sometimes people bring a Cyrex. I mean, Link, like the most common offerings that we provide is, those main four: Motec, Mtron, Link, Max ECU. And I think not every product that comes out of Technica's doors is like, full on F1 or, motorsport grade harness, but it's, something like it has to fit the bill. And we try to have the interests of the customer, be aligned with the scope of work and, just get them something that works. And we really specialize in those 4 engine management systems so that, we're, like you said, we're acquainted. We know how to wire each configuration, because when you put into practice things that are an inch wide but a mile deep, the skill that comes to building these harnesses, things get easier over time as we train our guys and our team. So I think that's, specializing in those four is like really important.
Yeah. I think we also are spoilt for choice these days. I mean, 20 odd years ago when I was getting started, let's be honest, it's probably a little longer than that, but care not to think about that. There weren't that many options on the market. I mean, I obviously, coming from New Zealand, we were affiliated with the Link brand from day one. And I mean, I'll be honest now, their early systems were terrible. They've come a long way and now they're producing a world-class product. But back in those days, you were really limited if you wanted something that could provide OE level drivability. I would say that your options on this side of the world were really Motec, or back then there was also Autronic. Obviously, there's some other brands from Europe and the States that would do a good job, but yeah, there weren't that many options. These days, for a modest amount of money, there's probably half a dozen ECUs that would be able to control an air-cooled Porsche pretty happily. And I mean, let's be honest, if you're talking 964, there's not a lot of technology involved in that engine. We don't have drive-by-wire throttle. We don't have variable cam control. My one doesn't even have boost control because it's naturally aspirated. So, simpler times with those vehicles, meaning that you can get a good result with probably a better result than the factory ECU of the time with a wide range of ECUs. Coming back to the question I said I'd put a pin in earlier, ECU configuration. So, like I said, you obviously don't have to be a tuner to wire up a car. How deep do you get into sort of the ECU configuration and setup as part of what you're doing?
Yeah, so at least for the configuration, I'm going to tie in what Phil kind of starts off with, and then how it arrives on my desk. Phil will develop a rapport and understand the needs of the client and have a scope of work with a build sheet. Once that build sheet gets to my desk on like what sensors we're running, what kind of intake system, and basically what sensor configuration and hardware is on the flat six, I start to put together a picture of what ECU fits the bill. So, dual lambda, if it's like a Kinsler dual drive-by-wire, obviously I'll pick an ECU that's more than capable of doing so. I'm a fan of using Mtrons in the sense that I have dual lambda, can do drive-by-wire. I have more than enough AV inputs to even run like 930 twin turbos. I just did one with oil coolers up front, two fans, just a coolant circuit for the turbos as well. Just about anything. And I still haven't packed it full of inputs and outputs. And there's a lot of room to go. And it's a pretty good budget friendly, solution. Whereas like Motec, you might need to keep stacking on those little add-ons like the LTCDs, and
Yeah, can quickly add up.
it does quickly add up. And normally for us, it doesn't really matter. But, you can imagine as a customer, like, what do you mean I need this firmware? What do you mean I need this module and I can't do a half bridge or dual half bridge circuit? What do you mean I have to do all these things?
Yeah.
So simply to cut all of that out, we just get something that fits the bill, whether it be a G4 Fury or an Mtron KV8. We try to just stay within that IO capability to get them something that's robust.
Yeah. How do you deliver the car back to your client, though? And I want to talk about where those clients are coming from shortly, too. In terms of, are you giving it back with a blank canvas in terms of the ECU, or are you going through it and pre-configuring the ECU for the sensors that you've installed, maybe getting it to the point where the car will actually start in idle, or are you leaving that to the tuner?
That's a good point. So most of the time, the way we operate, we mostly just send harnesses out with the ECU, and it's sort of a good validation sanity check for us to actually have a triangular mode of communication with tuner, engine builder, and us. Simply put, we know what the engine's going to need. I set up like a very, very rudimentary config, and once we finish the harness, I put it on a bench, and then we turn everything on. We do our little functional tests, after doing our continuity test and all of that. Basically, just load the base map, test every input and output with a wide range of sensors and actuators and solenoids that we keep in stock. That way, it's just, good sanity check on the harness.
So you're going to have the confidence that when the customer gets the harness and plugs it in, everything is going to work as expected.
Right. And there should be no surprises. Yeah.
In terms of your testing for the pinouts, making sure that that's correct, you just mentioned a continuity test. Are you doing this manually with a multimeter, just checking each pin is going to the right location, or are you using a high pot tester or something like that nature?
At the time and in the beginning, we were doing, manually with a multimeter. That's all we could have. We had no semblance of what serious high pot testers were. And then, as we grew and we attended conventions and started to kind of track and monitor what people at a high caliber are doing, you got to look like, if you want to act like a pro, you got to see what the pros are doing and kind of study that.
There's an expected level that you're working at of what equipment you're going to have in your premise.
Right. And so, we've eventually invested in those things and, calibrating and all that stuff. But before that leaves, it's going on the high pot tester. There should be no qualms about that.
I've used that term. I just threw that out there, and I realize probably a lot of people listening have no clue what a high pot tester is. Could you give us a quick rundown on what it is and how it works?
Sure. High pot tester basically just checks for not only continuity, right? Not to mention, a memory test of pin to pin on each connector end of the harness, but, it over voltage, it checks for over voltage. It checks for any cuts, any defects in the run from point A to point B.
So the integrity of the harness, as well as making sure that you've actually got your pin out correct.
Yes, that's correct.
Okay. All right, coming back to customers, it sounds to me like a lot of your business is business to business, basically building harnesses for shops, maybe specializing in the Porsche brand. How much is that business to business, and how much is business direct to consumer?
So majority of what we do is B2B. I think that over time it became that way. As we're starting out, it was a lot of B2C, business to customer. And we find it a lot easier to work with like reputable shop, especially when you do full EFI builds, because it's a lot more involved than just like doing a bolt-on carburetor build, restoration focus. But a full EFI build is a lot more intense, where we need to get a lot of aftermarket components. And especially within the wiring side of things, it's like a lot of people are still learning, even like the shops are still learning how to do an EFI build as well, especially within the Porsche market, because a lot of people are very old school. Even the sense of like introducing what PDMs are, there's a handful of clients that are willing to do PDMs because that's something they're already exposed to, but majority of the people, they are not. They just know like, oh, I know what's a standalone ECU, but I never heard of PDM before. So it's a lot of educating.
Yeah, I can imagine. And I mean, these days, using a power distribution module makes just so much more sense over fuses and relays.
Oh yeah, definitely. But like sometimes it just scares certain people unless they have been in a motorsport area before, or they have done similar builds using PDMs. They want it. But overall, working with other businesses helps a lot, helps us improve our craft, and if any feedback, or even just having repeatable work as well. A lot of people, especially in a Porsche market, they want to have a certain type of taste in the build. Like, for example, Silver Lake projects, they have a carbon fiber plenum, so they focus on just like I do Bosch drive-by-wire with a carbon fiber plenum, and that's his like forte.
Yeah, sure. Do you find as well that dealing mainly with businesses, you've kind of they already have a better understanding of what the job involves and basically where the price point's going to be, rather than dealing with a consumer who's maybe sort of coming in with a expectation of $1,000 harness in his mind, and obviously you're going to blow that well and truly out of the water.
Yeah, I think there's a couple things in an advantage working with B2B. Is one, the expectations are clear because they know what it takes to run a business, and you do. Defining the scope of work is a lot easier in the sense of this is exactly what I need. Maybe sometimes they give us like a drawing, like this is how I run my stuff. I like to tuck here and do X, Y, and Z. I like to use X, Y, and Z sensors because that's what they stock. And there might be some back and forth on what they do, but at least the expectation is more concrete and they're more exposed to it and they're more familiar. They even have a workflow based on how they, at what stage are they done with the engine and put the harness in and then load it back up in the rear. All of the things that we do at Technica try to accommodate to that because we know how it can be when it comes to running a shop. We try to make their lives easier, at least even in the design of our products, like how to have the ECU just come down, how to have it mock up in the stock location, clean result yet totally straightforward. But yeah, I think working with B2B is just they know what they want and they know how to offer feedback that's constructive to us and achieving the result that they need.
Okay. Just in the same vein as I was asking about your level of ECU configuration and what you're doing on that front. These days, CAN-based devices are becoming more and more prevalent and gives you the advantage as well of being able to mix and match between, maybe a different ECU versus PDM, for example. But there is quite a bit that goes into often programming the CAN messaging templates so that the devices can talk to each other. How involved do you get in that side of things?
As of yet, that's something I actually want to explore more. I am used to doing it. At least at Hyundai, I was introduced and trained into doing the canvas sniffing. So I do understand like the theory and concept, but in practice, because the Porsche market isn't so keen to catch up into utilizing all of the PDMs.
So it's not really such a critical item at the moment for your business.
It's not a critical item. And most of the time, if it is on PDMs, sometimes I do actually two things. I do it as like a kind of a fail-safe. I have CAN, so if they want to do complex functions, they have access to CAN, and I leave it to the configurator or the calibrator to do such a thing. But on top of that, I'll have some low side outputs and stuff like that to kind of command the request and response between ECU and PDM. That is an avenue that I am still, on a journey of learning and mastering.
I mean, ultimately, if your customer base is currently not requiring anything at that level, well, it's a no-brainer. You don't have to learn that. So, yeah, I guess in time that might shift and you might have to start adapting to what the market wants. But for now, that's fine.
Right.
Right. Let's dive into some of the sort of wiring specific elements here. And I want to start by talking about the different levels of harness that you offer, sort of a club level versus a motorsport grade harness, and what differentiates those two.
Yeah, so we primarily provide two versions of our harness, the club sport level and motorsport level. We're starting to introduce a third one. We call it like Pro Club.
Pro Sport.
Pro Sport.
Yeah.
And so kind of the first one is Club Sport. Club Sport is basically a TXL wires with fiberglass loom, and we put rubber boots in every connector. When there's a connector that doesn't have that serviceability of adding a rubber boot, we would design it in-house and retrofit it onto the connector so it can have a rubber boot.
And to make our own back shells and stuff.
And yeah, we make our own back shells in-house. So kind of the added benefit is you don't see any wires. So the whole harness looks more consistent. Two is more serviceable. Let's say if we make a mistake in-house or we need to like swap some pins, it's very serviceable. As Kevin spoke earlier, the fiberglass loom is very high temp and high abrasion resistant. So it's perfect for street car application.
I'll stop you there as well. You mentioned TXL for the wire, and I'm guessing you're going to tell me that at your top level you're using Tefsil. Then the other, I think this is one of the areas a lot of people kind of don't really give too much thought to. If you're just going to your automotive parts store and buying wire on a roll, you're quite likely buying something with PVC insulation. And of course, that's got quite a low melting point, so not really up to the task for engine bay wiring.
For us, at least, we like to offer at least TXL as like our base offering. GXL along the same vein is like a good substitute enough. But for us, TXL is pretty much like the way to go, at least for the club sport stuff.
Mm-hmm.
Just to make it more economical. Obviously, we can't discount the fact that Tefzel runs at a premium.
All right, so just looking at this sort of club level harness, safe to assume with TXL, with the club level harness, you are not concentric twisting. These are just straight runs of wire?
No, yeah, just straight ones of wire.
There's always a lot of debate when we talk about concentric twisting about sort of the pros and cons or usefulness, why we even do that. So I'm interested, can we get your take on that style of wiring harness?
Yeah, so I mean, really the reason why we concentric twist if and when we need to is to just maintain like a uniform harness. And I think a lot of the time it's not quite needed. Most of the time we would, if someone wants like the TEF cell and the DR25 finish, but don't want to pay for the man hours of laying, layer after layer, there's like a helical twist is enough to suffice. But really, the concentric twist is to make sure we have like this uniform core that is easily able to flex around tight radius, tight corners, and maybe you have a really tight channel that you need to fit all of these wires in. I think it really depends on what you're trying to do, but it's something that at least lets you have even tension, super flexible runs of wire in the car.
In terms of that, I think there is this perception that it's absolutely necessary. And again, as I mentioned earlier, that's what people are going to be seeing when they're scrolling on Instagram. But there are some of those advantages, as you mentioned. I think for me, if you want to use DR25, you can't really install DR25 over a wiring harness that's just a straight run of wires. It's just, A, it's difficult to get it over because you don't have that uniformity of the harness diameter, which you've mentioned. And B, when you recover that, when you shrink it down,
it looks ugly.
Yeah, it looks really ugly. So, I mean, that's my sort of take on it. If I'm going to be doing a harness where I want that look and feel of DR25 over the finished product, really at that point, the concentric twist for me is the only option I would go with. But you also mentioned correctly there the flexibility of the harness, which I think a lot of people don't give any consideration for. But when you're trying to route a harness through a tight engine bay, you do end up with some tight sort of 90-degree bends that it has to go through, and you've got to really hold a DR25 concentric twisted harness and try and move it in your hands to realize just how flexible it is, because each of those layers can move relative to the others, correct?
Right. And I think you made the point earlier about, if you just made a straight run through and recovered DR, if you did that after you recovering it and you bent it in the same manner that you tried bending the DR25, you're not going to get the same tension all the way around, and it's not going to feel great.
No, and it's not going to be great for the wires. That's the other aspect, is the strain relief that comes along with this. The idea with the concentric twisted harnesses, you're not applying any additional stress or strain to any individual conductor. They're all equally sort of, de-stressed, I guess would be the term there. So reliability in the long term should benefit from that as well.
Right.
There is the other argument about, the weight of the harness. I mean, at a high level motorsport kind of installation, every gram of weight makes a difference. I'm guessing with these Porsche road cars, probably not so much.
Right. Not exactly so much, but I think the one thing about Porsche people is that they can be a little bit picky about, how things look cleanly and neatly, and there's nothing wrong with that. I think making a piece of work in your harness, a lot of engineering involved that culminates to a really good result I think that's part of like the art form of making these things. But it's not so much art, it's how well can it take the abuses of what handling is going to do to it. And you want to create something that lives as long as the resto mod, right?
Yeah, correct.
It's really important to stress, putting good care into making that.
Yeah. Okay, I mean, in terms of a motorsport grade harness, though, concentric twisting and the TEF cell wire, that's only part of it. There's all the other elements that go into it, and typically here we're going to be using Autosport connectors for a bulkhead connector, for example, or we may need to pot a sensor or an actuator. Maybe you can't get the connector for those anymore, so potting and terminating those to an Autosport connector as well. So the whole level of the harness comes up, as does the expense, but that also requires some specialist equipment in order to work with the likes of Autosport connectors. Can you give us a rundown on, if a home enthusiast wants to start working with Autosport connectors, what's going to be required?
I think if you're not of the faint of heart and you want to start I'm not saying go and buy like a 128 pin connector and just start working from that. But I think, the Deutsche Autosport technical manual is an excellent place to start. If you just look at that, it tells you a lot of things. There's a lot of standards that are in place in that document alone that clearly define what good workmanship would look like and what a good result would be, because these are quality connectors engineered to withstand, the stress and abuse from motorsport environment, right? So what does it take to get there? How much to strip the Tefcel wire?
Seeing as you make that point there, I couldn't agree more about the usefulness of that manual catalogue. So much information in there. I think we'll try and actually link to that in the show notes as well if people want to have a look. But strip length of the wire, which is what I was going to focus on here. This is something that I think those getting started have absolutely no consideration for. If you go too short, you obviously don't have full engagement of the conductor strands inside of your terminal, your contact. So that could be a reliability problem, which is the reason why there is a little inspection hole, so you can actually make sure that you've got full insertion of the conductors. But the flip side of that as well is you don't want that insulation butted up hard to the back of the contact either, because that can be a stress raiser. So there is a spec on how much exposed conductor you should be able to see from the back of the contact to the insulation, correct? And can you give us a sense of what that spec should be?
Yeah, and then if I guess to take it on the other extreme, if it's too long and you have this like centimeter
No good.
long end of exposed wire just hanging out of a ASL or something, I mean obviously the wire is just going to fatigue and not even be sealed anymore by the rubber, so it's just going to be hanging out, and you have a fatigue point there. But the technical manual is really handy in the sense that it gives you what these strip lengths are so that you're within that spec that the connector was designed for, so that you have good engagement, you have good contact. And I think the other thing I didn't get to mention was like the contact sizing. I think a lot of beginners don't understand ampacity, why a certain terminal can handle a certain amount of amps. They might struggle with the idea that current and temperature have this sort of relationship. The easiest thing, even if it wasn't an Autosport connector, the easiest thing you can relate to is perhaps one of the plastic AMP super seals on a Motec connector or Link or whatever Amtron connector. They are able to handle 15 amps, but the thing that people don't think about is that they actually can handle more. It's not so much what the terminals can handle, but it's the plastic housing around them.
Start creating too much heat.
Too much heat and starts melting that plastic.
Sure.
But, in an Autosport connector, there's clear defined parameters on what they need to stay within for a factor of safety. How hot can each terminal get? I'm pretty sure that has to affect like the metal shell that they're all collectively heating up as, if you were to theoretically put that much current through them.
Seeing as you've brought up current handling capability, this is probably one of the more common questions that we see when it comes to wiring. Enthusiasts are getting stuck in for the first time. How do you know what size, what gauge wire to use? And really the actual question here is how much current do I need to be able to support? So could you give us a bit of a rundown from your perspective of how you calculate what the current in a given circuit is going to be, and then how that drives your selection of wire gauge?
Yeah, so I think I can make like a quick example, at least with a couple of instances. Sensors and like normal analog sensors and digital inputs they barely carry, they carry like milliamps of current. So we know that 24, 22 is like 22 gauge Tefcel is probably just at the sweet spot of what it needs to be, at least before yielding like tensile strength and stuff like that. We don't want it to be too thin. But if I were to design like a harness, keeping in mind like an ignition system, and I'm running power through a bulkhead connector, some of the things I'd want to think about is, where is the PDM or power distribution unit placed in relation to where the coils are going to be? Where are they being grounded? And just thinking about the path that energy takes on to complete that circuit would tell us what kind of loads we'd expect. And some of that stuff gets really in depth, if we're talking about an high RPM engine where the coil is just constantly saturating with energy, we can expect that if it's going to rev at like 10,000 RPM, we should see a certain amount of amps. We should be checking, hey, I'm running all this power through this bulkhead that eventually gets to my PDM. I should really check if those pins are worthy of kind of carrying that current that's going to be coming through them all the time. And having a sanity check of what duty cycle is going to be, how often are we running it at this RPM at a steady state? How long are we sustaining those types of load? Also lets us know, like, maybe we should think about safety factor. If the car just lives at 5,000 RPM or 4 or whatever, that's fine. But if it's going to be like a road car and maybe it's living at 8 to 9K or just constantly revving, getting to the top end of the revs, we should kind of think about that.
For those who maybe aren't following along here, what we need to think about is for the likes of a coil, and the same would be for an injector. We know that the injector, if we power at 100% duty cycle, so it's just switched completely on, it's going to draw X current. We can use Ohm's law to work that out based on the impedance of the injector, what that current will be. But of course, we hopefully are never running our injectors at 100% duty cycle. So,
Yeah.
if we calculate that in that particular circuit, let's say there's going to be 4 amps, just to throw a number out there, at 100% duty cycle. Obviously, if we bring that down to 50% duty cycle, something a bit more reasonable, then it's only going to draw half of that, so 2 amps. But again, where do we sort of size our wire gauge? What do we want to support? And it would make sense to safeguard ourselves. So if we do end up at 100% duty cycle, we're not going to end up with the wiring to our injectors melted. So I just wanted to get that in there in terms of what the importance of duty cycle on current handling capability.
Right. I think that's another novel concept to some beginners as well. Peak versus current, dynamic versus steady. And what conditions the engine's going to live at, and constantly demand versus maybe just a blip in the radar of what the highest could be. So I think you make a really good point.
That's actually really relevant with motors as well. So electric motor for the likes of a fan, there's going to be, let's say it might pull 15 amps steady state once it's up and running. But if you actually monitor the current draw, the inrush current when we first switch it on, when the motor's actually stalled and stationary, to actually get that up and running, it might momentarily draw, 30 or 40 amps. It's only brief. I mean, maybe for 100 or 200 milliseconds. Now, on that front, how much of a problem is that inrush current? Do we just ignore that and size it for the steady state running?
Yeah, I mean, I'm along the same vein of thinking that, if it's only for 2 like fractions of a second, obviously, that's not going to be sustained to heat the terminals and the contacts. You're not going to instantly melt over, say, 18 gauge TEF cell, which may be overkill for some things, but you're definitely not going to melt that. I think it's widely accepted that most of these systems are designed to understand what steady state and like what a constant running system would actually do to the terminals and all the contacts and all the wiring.
Yeah. It's quite nice as well once you've got a PDM where you can actually visualize that. You can log those current draws and see exactly what's happening. Sometimes that's actually quite scary when you get that visibility on things that you previously didn't. And some of the more advanced PDMs will actually allow you to set a fusing point for inrush current for a given time, and then what it will actually fuse at when the item is actually up and running steady state, which is quite a nice feature to add.
You make a good point in the sense that having logs is a good way of empirically gathering data. And one of the best things that we have as leveraging relationships with other shops is some of them do take their cars out. They're not all show cars. Some of them are track cars, and they really put the stresses of a track day. They basically put the harness through its paces, and being able to understand what the data had told them, like, hey, did you guys know that the coils are actually drawing like 4 amps, and somehow I thought it was 8 amps.
Next time
Yeah, next time we can make it lighter, but it's also like, no, we have good confidence in the safety factor of the harness. And so another point that you kind of alluded to earlier was like the weight and stuff. We're not in the point of competition where we need to shave weight for like a real performance gain. Um, Oftentimes, if we were to tell like a beginner, like, do I need 22 gauge? Oh, it's because the harness looks really thin. You can tuck it and it looks invisible versus like 20 gauge. I mean, honestly, like just running a 20 gauge just for peace of mind could be fine with them, right? So,
Hmm.
For me personally, I've kind of gravitated now towards building my own harnesses all in 22 gauge. Well, with the exception, I guess, of some of the more high current outputs for fuel pumps or radiator fans, which we were talking about before. But the actual wiring harness for the engine, I do all of it in 22 gauge. I think it sits sort of nicely in the realms of current handling capabilities versus mechanical strength, which is something that we haven't talked about before. When you're not trying to save every last gram, and let's be honest, most of us probably aren't going to notice if your harness is 100 grams lighter, it's going to almost be meaningless. But for some of the very low current circuits, you mentioned sensors where they might be drawing milliamps. 22 gauge would be complete overkill. You could go much, much smaller in gauge. But then the problem you're going to have is the mechanical strength of the harness in that area is going to be weaker, and all it's going to take is a clumsy mechanic trying to remove a plug from a sensor, and all of a sudden they've actually broken the harness. So those are the things that we need to keep in mind beyond just the requirements of the harness alone. There's other considerations that we need to bring in.
Yeah. So definitely intention when people are like pulling the harness and we don't want the wires to detach itself. So that's why we kept the wires towards a certain size. Basically, the thicker the wire, the more tension it can hold. Also, you also consider the contacts that we use or the terminals, what is preferred on those pieces as well, so we can get like a solid crimp. If the wire is way too small, even though we calculate the wire size, but if we couldn't get a good crimp, then it'll fall out, or we would try to over crimp it and destroy the terminal itself mechanically, and therefore we have a failure in that sense. So keeping, I guess, like certain rule of thumb over time, like within certain terminals, such as junior timer terminal, which is very common, those are basically Bosch terminals, and there's a certain standards and requirements and specs that comes with it. Certain techniques that we have performed is even folding over the exposed coils on the wires to beef it up more.
double folding.
Yeah, double
Like the
folding.
foldover method, just to meet the CMA.
Yeah, so what you're saying basically, some of these OE terminals really aren't compatible with very fine gauge wire. You're going to end up with an unreliable crimp essentially. Or if you try and crimp it tight enough, as you mentioned there, you're going to over crimp and potentially damage the contact or terminal.
Yeah, exactly.
Okay, so yeah, there's a lot of things to think about here, particularly even when we're dealing with 22 gauge wire. A lot of those OE connectors are not designed to work with such fine gauge wire.
Right. I mean, it'd be nice to give everyone a really skinny, light harness, but at the same time, that's with the understanding and assumption that they know how to treat them, and handle them, which not many people do. But, we try to keep like things fairly straightforward in our harness making. If we use the ubiquitous Deutsch connectors, we have those at our disposal, and we offer like the leads to our customers. Like, we ask them, hey, you haven't figured out what accelerator pedal you're going to use. Can you just give me a DTM6S? I mean, sourcing things like that, it's pretty straightforward to do if you can order one off of ProWire or something like that. Here in the States, we have ProWire and other sources to get those things easily, or Mauser or something. But if I just left things as like an Autosport ASL, the chances of somebody having that in their shop, it's like next to zero. That's just not going to be realistic in handing off a mating connector.
Yeah, sure. Well, I guess that sort of brings up the next question is connector choice for these higher grade harnesses. In the perfect world, I guess we'd want to use Autosport connectors everywhere. That's not always realistic. The DTM connectors have always been a sort of a go-to for me. In your opinion, these are still perfectly suitable for a professional motorsport grade harness?
Yeah, I think it's a very realistic thing to keep in mind. Most of the sensors that Race Grade or Motec or any other flying leads that most ECU manufacturers offer, they come in a DTM3S, and I'm fairly certain that they've taken those considerations in mind for the environment that they're going to live in.
Also, much better price than an Autosport connector.
Oh yeah, it's like yeah, let me just pay 3 times more than the sensor itself, maybe.
Yeah. I guess the other thing, I sort of alluded to this earlier, but I'll just bring it back up. The tooling that you're going to need to work with an Autosport connector, you're going to need a DMC crimp tool. I can't remember the last time I bought one of those, but suffice to say, not cheap. I'm guessing probably in a few hundred USD or thereabouts. Then all of the positioners that go with it so that you can work with the different pins and sockets for the different size contacts. There's a fair amount of investment that goes into this to get you up to a point where you can even start working with these connectors, whereas the DTM connector, you can buy crimp tools for those very, very cheaply. They're just about bulletproof and they're very easy to use. So it takes, I think, a lot of maybe the operator skill out of the equation as well to get a reliable result. Would you agree with that?
Yes, definitely. I mean, for the average hobbyist, it's hardly realistic to say I'm going to dump like $5,000 worth of tools before I can even attempt making my own club sport wiring harness or a motorsport wiring harness. I think everyone has to start somewhere, and the point you made is, stands perfectly. It doesn't have to be a DMC. You can buy one of those cheaper tools. You could find it on Amazon, or you can find them. I don't know. Yeah, I mean, you probably can find them on Amazon.
I mean, I think the one we've got a bunch of them in the workshop. I think the last one I bought was like $50. Yeah.
Yeah.
Mm-hmm.
Like if that, like it's really low entry, and it gets people in the door of, doing like it just introduces them the fundamentals of like what strip length is, the inspection hole, all of those things.
Coming back to strip length, I didn't mention this before, but that's also something I would recommend when you're shopping for a proper strip tool, is something that has an adjustable backstop, because particularly if you're pinning out a large Autosport connector with a lot of terminations, you're going to be stripping a lot of wire, and you want to get that strip length consistent, and having that adjustable backstop is going to achieve that. Am I guessing right that you might be doing this with an automated tool at your scale?
Yeah, that's exactly right. I mean, when we think of scaling, a lot of the times we have to acknowledge that there's human factors. You want to eliminate as much, variables that can go askew as much as possible to enact a consistent, calibrated, and concise result. I think there's value in doing things by hand, because I think when we all start out, we go through the woes of learning what it takes to make a good crimp. But then after a while, you should be able to preserve your hands, and you're only able to do as much as two hands lets you, versus automation being a beautiful thing, making things en masse and having things ready for you.
Yeah. I mean, it makes perfect sense when you're operating at scale like you are. Obviously, for the home enthusiast, it's going to make no sense, and they're not likely to have budget for that sort of equipment in the first place.
Right.
I also just wanted to mention here the Autosport catalog manual that you were talking about before. Another really common question we get with people just starting out working with these Autosport connectors, can be really confusing. You've got your DMC crimp tool, you've got your positioners. Now what? How do I know which positioner I need to use with which pin and socket, and how do I adjust the DMC crimp tool? And of course, you don't have to guess, because all of that information is clearly and concisely contained inside that manual, correct?
Right. I think it's a lot of, I mean, wiring is not for the faint of heart. It's a lot of attention to detail, almost to the point where it's maddening sometimes. A lot of people don't know, but even on like the Autosport connectors, just socket and pin sides of the bulkheads, they have a designation on what positioner to use. If it's like a K41, 42, 43, or whatever. A lot of guys like Joel, I think Joel Vince at Race-Spec, or Joey at ProWire, I mean, they are providing the information. I think when you go and search the tools, they do tell you what's the suitable like termination for what connectors. So they do a really good job of educating the people that are buying it. Also, like little reminders, like, "Hey, you bought this bulkhead. You might need this guy," which is
Yeah.
which
Makes
is
sense.
good for the community because sometimes not everybody gets there.
Well, there's nothing more frustrating than thinking that you've bought all of your consumables and then you've laid out your weekend to get stuck in, and then an hour into the job you find that you're missing something that you need to complete the job, and then you can't get it till the next week. So that's really frustrating. I'm sure we've all been in that position before.
The momentum killer is not having the right tooling or consumables for sure.
Totally. So far, we've talked a number of times about crimping, and I just need to get your take on one of the age-old debates of crimp versus solder. And anytime we bring this up, we're guaranteed to get some heated replies in the comments on both sides of the spectrum. Our stance has always been that wherever possible, we crimp, we don't solder. And my take on this has always been that solder, no matter how good a job you've done of soldering a connection, you're going to end up with a brittle section where the solder finishes, and if it's exposed to vibration and movement over time, it can fail. And the operative word there for me is can fail. Doesn't mean it's going to, but it has the chance that it could in time, because we always end up with people saying, well, I soldered the wire to my stereo back in the 1970s and it's still going strong, so obviously soldering's fine. And the reality is that, chances are it might be okay. But if we want to give it the best chance of living, we crimp. And then the next argument we get back is, but I crimped a wire and it pulled out of the terminal. Well, we're not talking about using a generic, cheap, off-the-shelf crimp tool here. We're talking about industry best practice standards such as the DMC crimp tool set correctly. Under those conditions, if I had to place my bets on a soldered versus a crimp joint, I'd be taking crimp every time. Can I get your take on that debate?
Yeah.
I'll let Paul go first on this.
So everything that we do, I would say 95% of what we do on a harness is crimping. You get a more mechanical hold onto either terminals or a splice itself. So when people pull it in tension, and if it's a solid crimp and it's crimped by spec and with the right tool, then it shouldn't fall out. And just like I can see that people think soldering is more like welding, but it really isn't.
I think the problem as well is it's not the solder itself, not the solder joint that's going to fail, it's where the solder finishes, right?
Mm-hmm. Yeah. And then you're not even getting something solid in there. It's always like porosity or like within the solder on the wire itself. But the only times that we do solder is, I think, very few times when a connector itself is required to solder just by the design of it.
The good old Motec UTC ports.
Yeah.
Yes.
Yes. Yeah. That's the thing as well. I mean, for every rule, there is an exception. So I can't sit here and say hand on heart, you'll never ever solder a wire when it comes to motorsport wiring, because that's simply not true. However, when we are required to solder, there are also ways in which we can negate the potential problems that come along with a solder joint, such as basically isolating any mechanical movement that's going to come from the wires being moved, pulled, or vibration. And on that note, I mean, one of the classic case studies for where we would solder in a motorsport environment would be potting a sensor or an actuator. So can you talk a little bit about that?
Yeah, I mean, so potting a sensor would just be having some. You've alluded to the situation before. There's a sensor that may not have a connector end that would live through the mating cycles or stresses that the OEM connector would have. And so, essentially, to make a long story short, you strip tough cell, you get it close with a good solder on to the terminations at the end of the sensor, and then fill it with potting compound and finish with like a Raycam boot or even Raycam SCL so that it's nice and sealed in there. But rarely do our harnesses get to that point because of the nature of not all of our harnesses are motors, like they require motorsport sensors. A lot of them are using like generic race grade DTM3 sensors.
Yeah, you could imagine if you're going to go ahead and pot every single sensor and actuator on an engine and then terminate those to an ASL connector, the price of the harness is going to be through the roof. So it's always choosing the correct application for correct technique, I should say, for a given application, I think is important to understand.
Yeah, I think it's important to keep the customer's project scope and budget in mind. You can always go for reach for the superlative solution, the best thing, but really for the customer's pocket, is it really the best thing? Just because you can say it's the best? And, we ask ourselves, what is it going to do? And they're like, oh, I just want to drive it on Sundays. It'll be fine. We don't need an F1 level harness.
Yeah, and probably a lot of these cars probably are also driven on sunny days, so sort of moisture ingress probably less of a concern there. Just coming back to the potting though, so just to sort of put a nice little bow around this, that potting compound or epoxy that we backfill the connector with, when that sets up, it's rock solid. So that's what isolates any movement from the soldered joint. And then you can double down on that because you mentioned you put a heat shrink boot over it as well. And when those are recovered down, they're essentially solid as well. So that's sort of a second layer of stress relief that's going to make that soldered joint reliable.
Yeah, and I think one of the things that I wanted to mention as well, I got a little bit off track, but I think you mentioned ingress protection and moisture ingress. And I think even if looking at the technicalities in ingress protection, IP67, IP69, people really don't understand that there are grades of that allow you to know what level of IP is suitable for the environment. And, taking that into account, that really helps us define what terminations and connectors we need for a harness to achieve some sort of result for the client. It's like you described earlier. I'm just going to drive it on a sunny day on Sundays. No need for potted sensors all around, remote mounted oil lines and anything like that. It's just a nice street car, and that's fine.
But I mean, even a lot of the more budget friendly connectors like the DTMs, and I don't have this information right in front of me, I'm probably going to get this a little bit wrong. I can't remember the exact IP rating of the DTM connector, but I think from memory it's rated to be submersed by a meter for 30 minutes or something with no moisture ingress. I mean, unless you're planning on putting it on the outside of your submarine, it's probably going to be more than sufficient for most automotive applications. So it's definitely a really good option at a budget-friendly price point, I think.
Exactly. I mean, they're the most universal. They're everywhere. They're economical, and there's no shortage of them. So
I think probably one of the areas you'd consider moisture ingress maybe a little bit more seriously, and I guess with moisture ingress we also need to consider it's not just moisture, it's also dust. But maybe in the off-road racing industry, these trucks, these vehicles are operating in some really, really nasty environments. There's lots of dirt, mud, dust, and then of course at the end of a weekend, quite often they're going to be cleaned down with a pressure washer. So, that might not be ideal for a lesser product or a lesser connector on that particular harness. So it's all again about making the harness to suit the application and what it's going to be subjected to, I think.
Yeah, I mean, considering the environment that these cars will live in and the stresses and abuse that they'll be subjected to, I think it's all relative, and people should really keep that in mind because it really paints a better picture of what kind of harness they're going to build for themselves, whether it be the Baja truck that you alluded to, or, I'm just going to get my dad's Super Beetle running again kind of thing. So there's a plethora of places in between that you could, spec a harness to be.
Let's move on. I'm interested if you have any common mistakes you see, people that are just getting into wiring making. Are there any common errors or problems you see and have to diagnose?
Yeah, I've seen a lot of horror stories, and even sometimes we fall into that category too, and that's part of the learning curve. But I think the biggest thing is planning. Planning before we start, or anybody or other people I've seen, they just get into it. And the harness becomes a lot more of a rat nest or become too bulgy, or they cut the wire too short and they're already too late. So there just has been a lot of like horror stories in that sense. I think what comes down towards the next level is when they start frying stuff before even really testing the harness. They start powering like the ECU or PDM and things become fried. Kind of one example is we work with a couple of college universities such as in Cal State Fullerton. We supply them 3 PDMs, link ECU PDMs, and they fried 2 of them in like a day.
Yeah. That's an expensive mistake to make.
Yeah, but I try to encourage them in the sense of like, hey, at least like the car's not on fire, but your PDM is, or like, or someone's hurt. And there's different levels. Like, but I tell everyone that like we're building harnesses, but these are going to cars, and people are driving these cars, so we have to take it seriously. Especially knowing where to ground, where to power. Don't mix those two. Like as what we talked earlier, like the wire gauges and crimping. Like yes, like it all comes down towards safety. And if we want the harness to work, we want the harness to perform well and even last. So those are the horror stories that we've seen from people who either inexperienced or just they're just building the very first harness. And I expect when someone even built the first harness, it's gonna look ugly. It's gonna be challenging, and they're gonna hate the process after the first time.
Yeah, I think it's the usual story. 10,000 hours to become an expert in any field. So yeah, your first harness is probably not going to be Instagram worthy, but if you stick at it, it's iterative improvements as you go. I am pleased that you brought up the planning part, because that is something that I see, and I've been guilty of this myself. You know, you've got a project in front of you, you've got a few rolls of wire, crimp tools, some flush cut pliers, let's go. But I think there's probably more time, at least at my level, more time goes into the planning, particularly if you're trying to plan out a concentrically twisted harness and, you know, what wires are going to be in what layers, etc., how you're going to step up those layers. That's a bigger job than actually constructing the harness. So I'll spend more time on the planning and documentation than actually making the harness itself. I don't know, I'm guessing you guys are probably a little bit faster than me, though.
Yeah, just wanted to elaborate on the planning a little bit. But, oftentimes we get word from shops late that it might be like, oh, by the way, we have a secondary electric water pump. Can we throw that in there? And I'm like, the whole harness is like together. Everything's been twisted over and shrunken down. It's really hard to rip that all out and start all over again. And I don't know how I'm going to bill you for that. And, sometimes you just have to do what you got to do. And, it won't be pretty, but you tell them, hey, it's just going to be outside of the existing harness. It's still going to work. It's just not going to be as pretty as we discussed when I was fitting the harness at your shop. But sometimes, like the planning, even at least for the motorsport grade harnesses, is a big thing, getting like the sizing down. And it is a bit of a reality check that it doesn't have to be the smallest, most like the thinnest harness on earth. But it is important, at least when you start making like transitions, try to envision like, I'm going to have these braided wires in my core. I'm going to have all these wires twisted around it. And the outermost is probably going to be like a lay that kind of breaks out first, so that after all of those things have been peeled back, you still have the core that's making its run to where it's supposed to be. Things like that you only get sometimes from experience, because you're like, oh, my transition's super bulky. I have all these wires folding over each other, and it looks like they're kind of fighting each other, like a tangled growth almost. And it's really hard to hide in a brake cam boot.
In the perfect world, that's what I try and do, is plan my layup so that at the first transition, I'm only using conductors from the outer layer. But of course, life isn't always that simple. You can almost guarantee at some point you're going to need a shielded cable from the core. I'll always use the shielded cables as the core, because they kind of like get a bit ugly if you're putting them on an outer layer. So you're going to need to break that out sort of 500 millimeters into your harness, and that's a bit frustrating, but sometimes that's just how it goes.
Yeah. I mean, other mistakes that I see people do, I think it's like not taking a step back and asking yourself, like, what am I doing here? Like sometimes people get so in, like they chase these little things, these little problems, but they don't take a step back and ask them, like, how does this amount and culminate to the result that I set out for myself? And like focus their energy a little bit better on maybe it could have gone to the planning, you know? I don't know. Sometimes, because they're just like racing through and trying to rush making a harness, they don't really take a time to pause and think about like, do I have all my powers like lined up? Do I know how much current I'm carrying? Is the gauge like, let me just double check the gauge size on the wiring for the powers and grounds. Let me make sure that I have a start point earth. Am I forming any ground loops? Where am I terminating all my solder drains or my shield drains? Is this the spec as the ECU kind of commanded? Did I even read the ECU notes? Sometimes I think we're all guilty of this, and you try to call Motec for help sometimes. Some folks are like, hey, we do have this note on this drawing of X, Y, and Z. Did you read that note? I'm like, oh my God, I didn't. Let me look at that again.
I think that kind of goes full circle back to what we were talking about earlier about familiarity with a particular brand of ECU, because they all do have their little idiosyncrasies. And as you mentioned, probably it's noted on the wiring diagram, but that can also be easy to overlook. So that can end up really tripping you up. Now, you just also mentioned a term there, star point earthing. And I think probably earthing issues are one of the more common ones that I see. Can you tell us what star point earthing is and what we need to be doing when we're designing the earth path for everything?
Yeah, so I mean, star point earthing or star point grounding is a method of harness building that entails having a centralized point to serve as the ground, as the hub, and everything that stems from it kind of forms like a star, or every device that is grounding is a star. That way, they all have the same reference ground for either the coils or the ECU. Because you can imagine if you grounded things, if all of your grounds culminated to a point after the ECU, once electricity tries to find a way to ground itself, the first place that it sees is maybe after that ECU, and then your PCBs might be a little toasty,
No one likes the smoke getting out.
and no one likes the smoke. So, and for simplicity's sake, I mean, to have a shorter run path in ground where everything is in a centralized point, it might make the harness run shorter. Therefore, electricity follows a shorter path. You also have less voltage drop on a longer wire. It makes a lot of things simple and straightforward to make, instead of like tacking all these grounds at different points of the chassis and having different voltages across each part.
So I guess most enthusiasts would be thinking, all right, my ground point, we could make this, maybe everything runs to the battery negative, or maybe we ground the battery to the chassis and we choose a chassis point for the ground, or we can do it on the engine block or cylinder head. Where should we be doing it?
Most of the time we follow like to the cylinder head. If you really wanted like a clean earthing point, right? If you wanted to take all things considered, for all the other devices that want to go to battery negative, there's always bus bars as well. But for the sake of simplicity, at least when we make our harnesses, it's very simple. There's three grounds that do get taken to the cylinder head. It's our ECU grounds, and then obviously our coil grounds, which are not too far along. They're right on the same stud. In that method, we practice the star point grounding anyway.
Yeah. I think, just really important to understand how critical that can be in the reliability and operation of your ECU. I've seen that so many times with cars that would come into me to be tuned and they've been wired up in the home garage by the enthusiast, and the grounding's just all over the show, and it can cause some really big issues. Coming back to planning, I mean, my general way of documenting my harness builds is just with a Google Sheet. It's hand done. It's not particularly difficult. There's no technology in it. And then I will draw out just on a piece of graph paper the layout of my harness, where all the branch points are, where each is going to, the length of each of the branch points, and then document, what the connector will be, what the boot will be, etc. And then I'll take a photo of that and I'll upload that onto my Google Sheet as well, so that I've got everything in one place. It's all, on the cloud. It can't get lost. But there are also professional harness design software available. I'm just interested, how do you go about this?
Yeah, so, to keep it simple in its own, at least in the operations side, we keep it really simple with Google Sheets and our Google Drive. And we also have just Excel we just use Excel. And the visualization of the harness layout, at least, is all done with Visio, Microsoft Visio. I'm pretty OCD about making my connectors look like what they're supposed to look like, instead of like an obscure box. It started out being like with PowerPoint with little circles and, dot to dot draw diagrams. But as I started learning more and more, I wanted to level up. That's basically what it came down to, is just, hey, let's simplify it. Let's just use Visio and Excel.
So I've never used Visio myself, but plenty of people that I talk to in the industry, such as yourself, do. And from what I understand, the problem with using Visio initially is there's no library of the Autosport connectors, the boots, etc. So you created all of that yourself?
Yeah, and I can't take all the credit. I have some friends that have loaned like little Ray Cam boot diagrams and stuff like that. But you can spend hours just having fun making connector block diagrams to actually look like a side view of an Autosport connector or a Ray Cam boot. But after developing that library long enough, you have the everyday things that you use that you drag and drop in an object-oriented environment to make your harness layout. But yeah, that's pretty much what we use. And you don't get to start out with a library, like you said.
Yeah, I thought it's probably important to set expectations to our listeners who are going to jump on Visio now and wonder why they don't have a full library of Autosport connectors available.
Right. Yeah. The only professional version is called Hardware by TE Connectivity. But again, the license for that is such a steep barrier to entry to even access that library, to even have like the support for any of that. I just thought, hey, I don't have that money. I'm just going to make it myself.
Yeah, I mean, I would guarantee that 99.9% of our listeners also are not at a point where purchasing a license for hardware would make any sense. So it's good to know that there are these alternatives. You've upped your level from what I'm doing with a hand-drawn diagram, but there's also absolutely nothing wrong with a hand-drawn diagram. I guess when you're providing this documentation to customers that are paying thousands and thousands of dollars, there's an expectation of professionalism that comes with that. So the hand-drawn graph paper just ain't going to fly.
Right, yeah, there's times when we had to fly out to a race team or a bespoke build, and we have 1 or 2 days to measure the car. So we have to come up with a technique that makes sense based on the time given to us. So from there, we use like paracord and mock up a harness, like a physical mock-up on an engine or a chassis or both. And the clients can see, okay, this is where we're going to mount the ECU, this is where we're going to mount the sensors, etc. And it gives them that physical like layout, and we can take that and go back to our shop, but we will fly back and we have our, I guess, layout like a paper drawing, right? So we can take our time creating a more professional drawing and even double checking the lengths. But in a sense, we have to use different practices. If someone were to bring their car to us, we have more time to design and make sure we capture every detail. But being like a wiring harness designer and manufacturer, most of the time people want us to go to them. And it's because they're dialing everything mechanically, things are more heavier, that they had to move around.
Can't just ship a car.
Yeah. Not all the time.
Not all the time.
And then versus they can fly us out and we just have crimpers and wires and notebooks and our laptops just to kind of do the preliminary designs from there. Choosing the right task for the right job. It's all time. Like people want to build these cars sooner than later.
Yeah. You got to have some options of flexibility in that regard, I think.
Yeah, I mean, we're not able to be as flexible to deliver things yesterday sometimes, but we do our
Still haven't created a time machine.
yeah, but we do our best to work with our clientele.
Sure. All right. Speaking of time, I think we've probably kept you long enough. So I'll move towards wrapping this up, and we've got the same three questions we ask all of our guests. The first of those is, what's next in the future for you guys and Technica?
EFI is what we love to do. It's a lot more involved in the harness building. We have to think creatively, like trigger wheel setup, cam setup, induction system, and we just love working deeper rather than just like sticking with just OEM. And a lot of people have been asking us, like, "Hey, what about the Alfa Romeos? What about the
Mercedes
Mercedes Benz or the BMW crowd?" Like, people want the same level of work that we do. And the biggest thing that I preach to people or share to people is that, yeah, like you get some cool like ITBs, or you get a nice wiring harness, or you get like new aftermarket, like etc. But the biggest thing that we offer is tunability, reliability, and the whole car becomes turnkey, because nowadays a lot of carbureted systems are, well, they're currently not as reliable and people are still running them, and just fuel injectioning their system is the way to go in my opinion. And so definitely the market is just opening up more and more as people.
So just basically, you're going to be taking what you're doing for that Porsche market at the moment and expanding into these other marques.
Exactly.
Yeah, makes a lot of sense. All right, next question. Is there any advice, and you guys can answer this separately, any advice you'd give to a younger version of yourself to help reach where you are today in your career faster?
I think the biggest thing is to have faith and don't be afraid to take risk. It took a while for Kevin and I to like swallow that and wanting to make the jump and start our own business, especially within our age. We're not super young, but also not super old, but just a nice place to be at. But we think about like starting a family or getting married, and the expense just gets heavier as you get older. But yeah, just to not be afraid in that regard, and that will be, there's people around us, our loved ones are supportive and willing to take care of us. So just being grounded in that, and also like constantly learning and growing, like never get bored.
Well, I think that's one of the great things I love about this industry is that technology is always changing, so there is always something new to learn. I mean, here I'm going to assume this goes for all around the world, but as I was getting involved in tuning, and there were a handful of top tuners here in New Zealand that everyone sort of looked up to and respected. And what I saw was gradually they sort of tapped out at a certain level of technology and didn't want to learn about the newer systems coming through. So I've tried really hard myself to not let that happen. I don't know, it may in the future, but for now I'm always keen to jump into the new technology that's coming out, learn about torque-based tuning systems that some of the aftermarket ECUs are now introducing, and all of that sort of good stuff. So yeah, I just can't get enough of that. Did you have something you wanted to add in there, Kevin, in terms of that question?
Yeah, I think try to enjoy the ride. Sometimes I get guilty of being too hard on myself or taking myself way too seriously. And it's a little bit of a bummer when you're so passionate about something, and when things don't turn out the way you want it to, it's easy to have a very adverse negative reaction and be frustrated, be upset. And it's okay to feel that way, but also being more positive and healthy in the sense of like, okay, well, it didn't work out how I wanted to be. Like, what did I learn and what can I do better? I don't have a time machine yet. I can't change the past. And so, like, how do you just move on from what you learned instead of beating yourself up? I think took me a while to really grow out of that. And, now that we have grown and we have staff and we have a larger shop other than our garage and it's just not us anymore, we're trying to kind of convey a message of like, hey, like wiring's hard. You're going to make mistakes. Things are not going to be perfect. That's why we're training. This is nothing more different than a gym. You're here to train and get stronger and better and improve your skills, and just having a more healthy attitude about mastering your craft. I think that's something that's really something that I've like tried to embrace more and more every day.
while chasing perfection and all of that stuff.
I think those are all really good points. I think it's easy to get down on yourself when you've made a mistake or something hasn't gone quite right. Probably fair to say, though, we learn more from our failures than we do from our successes. So I think it's all about just taking it on board as a lesson, move forward. What can I do next time to make that better? Last question for today, guys. If people want to follow you and see what you're up to, maybe they want to engage your services, how are they best to do so? What's your website, social media, etc.?
Yeah, I think the one that we keep up the most is our Instagram. Just like our daily stories, our daily posts, and we start hosting some events like Cars and Coffees, or getting involved in like big Porsche events such as Loop the Goat or Air and Water. So and that's where we're able to interact with people within our market.
A lot of the handles are pretty much universal in the sense that you can just spell out Technica. It's like technical minus the L, and then Racewire, and then
That'll find you on all of the socials.
yeah, we don't have a TikTok yet. I apparently people keep telling me you should make a TikTok, but I guess I'm too old for that. I don't know.
I've resisted the urge to download TikTok.
Oh yeah, it's
I waste more than enough time on social media with just Instagram, so I don't need to waste more of my time. But I get it. That's where the young crowd is these days, I guess.
Mhm.
I think taking delight in what you've worked so hard in, and just taking a step back and appreciating what you made and all the things you studied for to make it to that point. I think that's like, I don't think people maybe do that enough when they do it, because they're so like in the weeds of like, oh, I just got to get to this next point. I got to get to this next point. Customers got to get it soon. Holy crap. It's almost Friday. Sometimes I just tell my techs like, it's really nice. Like, you did a good job. Like, you should soak it up. Okay, now it's going in.
Mhm.
You know, take a moment to look at it and like appreciate it, and then
Yeah, for sure. All right. Well, as always, we'll put links to your social media accounts and website in the show notes to make it easy for people to find. Really enjoyed the chat today, Kevin and Philip. Thanks for taking the time out to come on the podcast. And when I'm in the market for a harness for my 964, maybe we'll reach out rather than going through the exercise of making one.
Yeah.
oh, you bet. Yeah. No, thank you, Andre. I appreciate, being able to sit here and talk with you. I've been listening to this podcast for a long time, and to be on here is pretty cool.
Yeah.
And to talk to you is pretty cool.
Yeah, likewise. I think like I learned a lot from like your channel, not just only with just wiring but many different experts sharing about what they know, what they've learned, and it just definitely helped us grow a lot, and getting us, like building our fundamentals, especially in the beginning. And I'm even having my new guys here just listening to all your podcasts and training videos. So it's definitely really like helpful.
It's a very deep well of knowledge to have really good awareness of what others are doing in the industry, and it's really cool to be a part of that.
Love the feedback. Thanks, guys. All right, we'll leave you to it. I hope you've enjoyed this episode of Tuned In, and don't forget, by using the code podcast500 at checkout, podcast listeners can get a huge $500 off our VIP package, which includes over 40 current courses, as well as a long list of courses to be released in the future. As a VIP, you'll also get lifetime access to our members-only webinars and our community forum. Lastly, we'd love it if you could drop a review on your chosen podcasting platform. These reviews really help us to grow our audience, and that in turn helps us to continue to get more high quality guests. To say thanks, each week we'll be picking a random reviewer and sending them out an HPA t-shirt free of charge anywhere in the world. This is also a great place to ask any questions you might have too, and I'll do my best to answer them if your review gets picked. So this week, a big shout out to Pavlo VR from the US, who has said, the most detailed knowledge sharing in the automotive industry. As a former racing engineer and a car tinkerer, there aren't many sources to learn new things from, this being the exception. The host and his guests are exceptionally talented people who don't hold out on secrets in their trade. My absolute favourite to listen to. Well, thanks for that high praise, and I'm really glad to hear that you're getting value out of the podcast. If you get in touch with your t-shirt size and shipping details, we'll get a fresh HPA tee shipped straight out to you. All right, that concludes our interview. And before we sign off, I just wanted to mention for anyone who's been perhaps hiding under a rock and hasn't heard of High Performance Academy before, we are an online training school and we specialize in teaching a range of performance automotive topics, everything from engine tuning and engine building through to wiring, car suspension and wheel alignment, data analysis, and race driver education. Now remember, you've got that coupon code. You can use podcast75 at the checkout to get $75 off the purchase of your first course. You'll find our full course list at hpacademy.com/courses. Important to mention that when you purchase a course from us, that course is yours for life as well. It never expires. You can rewatch the course as many times as you like, whenever you like. The purchase of a course will also give you 3 months of access to our Gold membership. That gives you access to our private members only forum, which is the perfect place to get answers to your specific questions. You'll also get access to our regular weekly members webinars, which is where we touch on a particular topic in the performance automotive realm. We dive into that topic for about an hour. If you can watch live, you can ask questions and get answers in real time. If the time zones don't work for you, that's fine too. You're going to get access as a Gold member to our previous webinar archive. We've got close to 300 hours of existing content in that archive. It is an absolute goldmine. So remember that coupon code podcast75. Check out our course list at hpacademy.com/courses.